welcome everybody to this edition of Exail. My name's David Cunningham. I'll be your host for this webinar. I'm here in Paris at Xblue HQ, and we'll be joined shortly by a colleague of mine to discuss the SeapiX sonar system we're going to look at today. So the idea of the webinar is to come to you live and direct with some news of new products and new innovations from Xblue in the absence of the opportunity to meet at trade shows around the world. So the format will be around about a 10 or 15 minute discussion or presentation about the product itself, followed by a question and answer session. So please post your questions that may come up during the course of the presentation on the webinar platform. There's an area on the right hand side where you can just post your question. So we will answer all your questions. After the event, we will post a recording of this webinar on our website, along with let's say an FAQ, a document covering all the questions and answers that have been raised in this webinar, and also the one that we'll do later in the day at 5 p.m. French time. So that's enough of the admin. So I'll introduce you now to my colleague Maxence Rioblanc, who's based down at our sonar factory in La Ciotat in the south of France. Welcome, Maxence.
Good morning, David, and hello to everybody attending this webinar. I'm very pleased to be there with you today.
Great. So Maxence is he's the product manager, as I say, for the SeapiX product lines. And maybe, Maxence, you could start by just introducing SeapiX.
Yeah, I think it's a good starting point. The SeapiX is one of our main products in La Ciotat factory. So it has been designed for the fishery markets, and we already delivered 100 of them worldwide, even in very remote areas like Alaska, Falkland Islands, Greenland, all this place where you can find a big spot of fishes. So it was designed for installation, permanent installation on board vessels. So you can see it's just on your left, David. It looks like this is a real one here. So it's quite massive to be robust, and it's ruggedized to face all the situation with the fishery vessel. So what is important with this product, which is quite unique, it's a 3D multi-beam echo sounder. And it means in this one, you have like 2 multi-beam in only one unit. The yellow line, the black line you can see is actually the antennas. So both of them can transmit and can receive. So it makes this product very unique. And this is what you call a solid state multi-beam echo sounder. So we can illustrate with this animation here. So you can see 2 blue moving parts in this animation. We call it a swath. This is actually the acoustic pattern that we can create with a SeapiX. So we can steer with one antenna or the other an acoustic beam into the volume, which is 120 per 130 degree. And from this swath, we can build bathymetry, we can measure the backscatter value, we can monitor the water columns, or you can imagine for the fishery vessel that they want to spot the interesting fish schools. They also want to see the environment which is around these fishes, because maybe they are bottom trawling, so they need to adapt the net above the seabed. And something also interesting, this is a metrology tool. So it's not only about detecting or getting a signal, but the signal we receive is calibrated at our factory, so we can give a good assessment of the biomass and also the nature of the sediments here.
Okay, so in a nutshell, SeapiX is an established product. It's been developed originally for the fisheries market. It's a 3D multi-beam with 2 swaths which scan 120 by 120 degree cone. There's hundreds in the field in this main application in the fisheries domain. So now maybe you can just explain a little bit now here. We're talking about SeapiX-C, the construction variant of this product. Maybe just explain a little bit the reasons why we've developed this product.
Yeah, I know at La Ciotat we don't deal only with fishery industry, but also with ocean science. So we meet a lot of customers with very challenging application. And we discussing with them, we thought that, oh, maybe the SeapiX could answer this. So it's why we created the SeapiX C. C stands for construction, but you can imagine it's a little bit wider than only construction. Something very interesting and important here is that we have an existing hardware, which is the one we deliver on the fishery industry. So it's exactly the same hardware, the same antenna, and also the same software, basic software to control the unit. So it's not really a new product. This is a shift from this product to other applications. So we develop specific application to answer the challenges of our customer, but we keep the reliable, the robust, the sea-proven design that we manufacture for years now. Another point is we want and we try to make it an easy-to-use tool. So you can imagine with fishermen, they only touch 2 buttons and that's it. So they don't want to tune or to set the system depending on the conditions. So that's something we keep in mind with this product, and we don't want to have skilled people or surveyor on board to use the system. And the last point is it was designed for a permanent installation, but we also have a light version for on-the-fly demonstration or measurement.
Okay, so it's an evolution of the existing system. The hardware remains the same, except that we have an additional lightweight model, let's say, but the software has been adapted for other applications. So what sort of challenges do you see this sensor addressing in markets outside of the fisheries?
Yeah, in marine operation, we often meet the needs to or monitor the water column or to give evaluation of the seabed, so like bathymetry. And currently, there is no satisfactory solution for all this application. Of course, you can find on the market multiple eco-sonder that can build very nice bathymetry, but it requires a vessel with skilled people. You need to travel over the seafloor to get a good bathymetry. And in some applications, that's not possible, or that's not safe, or it's not convenient enough because you need to do it now and you don't want to hire somebody that comes, etc. So that's something which is important. Also, another part, you could find acoustic cameras that give very nice picture, like a little bit like photography. But here you don't really build bathymetry, so you don't get the X, Y, Z, but more like a view of what are the objects on the floor. And also this is high frequency instrument, so you are affected by the turbidity, and in some cases you can't really use them.
Okay. So it's a unique tool in a sense, and giving you this sort of opportunity to do static and kind of real-time bathymetry. And so in terms of applications, what sort of application areas, broadly speaking, do we look at?
Yeah, you can imagine a lot of applications. We have a bunch of them in mind. Everything where you need to control what you're doing on the field, and you don't want to ask somebody with a specific tool. So something that can be used by the operator. Or you can imagine all the installation, a permanent installation that gives a report every week, every 2 weeks, to give an evaluation or the evolution of something which is moving on the floor you are looking at. All these kind of applications are in our mind. It can be from the safety of the operation to the control of the work which is done by the operator.
Okay, so any amount of different sort of monitoring or inspection type applications, either static, permanent, or temporary installations. And now what we're going to do now is have a quick dig into some case studies that I know that you want to focus on. So these are some, let's say, conceptual ideas, but also some real ideas and some real installations. So number one, I know that the number one application that you wanted to discuss was about dredging. So let's have a little look at that.
Yes, dredging is a very good example where you could use SeapiX and bring the innovative features of SeapiX on the field. We have an example here to display, which is an installation on what we call a backhoe dredger. So these platforms are used to dredge sediments and to maintain certain level of depth to this area. In this installation, we put a SeapiX just below the crane. It's a little bit tilted forward, so we can manage a good coverage, at least the same or more than the crane operating range. And here the purpose is to give a refresh of the bathymetry before the operator moves to the next spot. Today, with this kind of platform, that's very complicated for the operator because it's completely blind. He has already a nice bathymetry, which is built by a multi-beam echo sonder. He has a centimetric positioning of the bucket. So it's like playing a Pac-Man game. He knows where you have to grab the sediment and remove it, but he has no control of what he's doing. So if something is dropping or he missed a spot, he has no way to know about. So usually what they do, they try to flatten the seabed with the bucket at the end to be more or less sure. So that what we want to do is they want to be very sure before they move to the next spot. And this is why we want to integrate this SeapiX in this condition. Something we need to point out is the software integration is important here. It's not currently existing. And what we want is to have a one-button instrument, so to be integrated in the existing software, where the operator sees the crane, sees the sediment, and then the SeapiX is used to refresh the bathymetry in real time. So he knows exactly where there is missing spot and if there is any over specification dredging, this kind of work.
Okay, that's really interesting. So the idea is that the sonar will be mounted from the barge on a pole, looking forward into the work area, and then give the operator the opportunity to capture the bathymetry in real time, just to check the work check the progress of the work. The idea being to introduce some efficiency, additional efficiency into the operation. And so the key thing here is the sonar is ready to go, but actually integrating that visualization into the environment of the dredge operation obviously needs some work with the partner to make that happen. Okay, that's really interesting. So the next case study again is another river-based inspection job. So this is some work that you've done recently on the River Rhône. Maxence, tell us about that.
Yes, correct. We have a lot of requests about fresh waters like lake of river inspection. I can give you an example with a customer we did some demo with. They are electricity producers. So from the Rhône River flow, they produce electricity. And they have two main challenges and they don't find a good solution for the moment. The first one is to manage and to control the sediment on the river bed, because this sediment will move and will come closer and closer to the electricity plant. And what they want to avoid is to stop the flow, because they won't produce electricity anymore. So they need to anticipate this and to monitor this. What they have today is that they hire a vessel with a surveyor to go here every maybe 2 months or after an event. So that's not very comfortable for them. So what they are looking at is a fixed monitoring system, so they can see in real time and week after week the evolution of the terrain and then anticipate the dredging operation. The second side, the second application they have, and we'll have a small illustration here, is the monitoring of a pump, which is used to enable the traffic on the Rhône River, because here you have a big dam on the river and you need to ensure the traffic of vessel. Rhône River is quite a big river, so with a lot of traffic. And this is a state requirement, so they produce electricity from the Rhône River, but they need to ensure this flow of vessel. And here in the illustration, this is also a good example of opportunity installation. So they drop the light version of the SeapiX, a little bit tilted, like 30-degree tilted, so they can see from the surface to a little bit to the pier. Here you can see the lock on the right part. And the interesting area is the blue, the dark blue spot where the pump is located. And what they want to monitor is if there is sediments entering because of the flow of water, and that will maybe create a failure in the pump, so they can anticipate and look at this. To give you an idea, this setup, there is about 10 meters water depth. We are 2 meters below the water. And the deepest water, the dark blue, is about 14 meters, and the yellow part is 6 meters. So it's higher than the SeapiX, not the SeapiX, but higher than the rest of the bathymetry. So the largest side is 40 meters, and the smallest is only 20 meters, but because of the shape of the floor here, so it's preventing the beams to reach after the yellow spot here. So that's quite a good and interesting illustration. Maybe a last point about this setup is we have an integrated, a built-in IMU inside the acoustic. So when you drop it in the water and you tilt it, it's automatically give you the roll and pitch of your system. So you can have a quite a good view of your area without any settings. So you can drop it, install it, plug it, and in a click you will get the bathymetry on live.
Thanks, Maxence. So in that instance, the idea is to monitor the scouring or the buildup of sediment around the intake of a pump for the lock on the River Rhone. And in this particular instance, you arrived with a van, with the system in the back of the van. You deployed it on a pole over the side of the quay in order to build up that really quick measurement of the situation. Could be deployed permanently or in a temporary fashion and very mobile from the side of the river, taking away the need of mobilizing a vessel to that location. Really interesting. And we've got one more that we want to look at, which is it's an installation, a real installation on board a jack-up barge of Pent Ocean. Tell us a bit about that one, Maxence.
Yes, actually, this is our first customer about SeapiX, so it's a very good example here. And in that case, we provide a full solution from the acoustics to the software. So I will explain a little bit later. Just to give you the idea, is Pent Ocean is building wind farms at sea. So they use big platforms, we call it self-elevating platforms, to transport the turbines and to install it at sea. So usually when they go on the site, they already get a nice bathymetry because they want to be sure that they can install the wind farm here. But they always want to control when they will put the legs down. They want to be sure that it's safe. So the safety is what about the flatness? So they want to make sure that the good area where was the previous bathymetry survey was done. So they want to check if it's good. They want to check if there's new obstacle, so they don't want to damage their foot when laying them. And finally, they want also to see the existing structures. So you can imagine the concrete mattress, which are used to avoid the erosion around the turbines. So they don't want to crush this. They want to be just as close as possible, but not crush these structures existing. So I have a small illustration to show you and to explain the setup. First, on your left, you can see that you have not only 1 or 2 or 3, you have 4 units used at the same time. And this is also a feature of the SeapiX. You can have what we call the multi-head capability. And from the customer point of view, it's completely transparent. You can have 1 up to 4, and it's exactly the same way to use. The only difference is that when you get the result, you get more spots at a time. On the right side, so on the top view, you have the 3D view, which is in real time also, where you can display mobiles. So on mobiles, I understand the platform itself, but also the legs. So here we have 4 legs on this platform. And we are integrating also what we call the leg monitoring system that gives the extension of the leg. So in real time, you can see your platform and your leg deployment. You can display also automatically the bathymetry and the acoustic view. So you can have also the intersection between acoustics, the legs being down or up, and your bathymetry. So that's a good real-time assessment of your environment. Just below this, you have the 2D view, which is more like a plotter view. This is good to have like an eagle view of your platform, so you can see where you are exactly, and you can integrate IIS and other plotter features in this view, and of course the bathymetry itself. We don't see it here, but we have also real-time value that are given, like what is the distance between my leg and the seafloor just below the legs here. I want to point something here. The SeapiX is completely new for this kind of application. And usually what they do, and it was to use divers. So they send divers just below the 4 legs. Imagine the size of the legs here. It's not the biggest platform. They have other platform in mind, but this platform, the legs is 7 meters by 7 meters. So imagine a diver being sent here, trying to check if it's free of obstacle in maybe dark condition. So it takes a lot of time. It's not always very safe. And so they want a more convenient and real-time assessment of what is done. And the operator itself is a leg operator. So it's not a surveyor, it's not a sword people. It is really the operator of the leg that manage in real time the legs and monitor that, okay, everything is okay, I can put my legs on the floor.
Excellent, thanks for that, Maxwell. So it's a real installation with four SeapiX systems integrated into one platform, one on each corner, and integrated into the same kind of visualization system. And what we were looking at there was obviously just a graphic imagery of that installation, but then we were looking at real data from some tests and trials that we'd done prior to the putting into operation of the system. Really interesting application. That's great, Maxence. So we've had a quick look at the sonar itself. We've had a quick snapshot of a number of case studies. What we're going to do now is go to questions and answers, Maxence. So I hope you're sitting comfortably. We've got some questions. Can SeapiX-C be mounted in different orientations?
Yes, you don't need to be downward. You can be sideways, forward-looking, or backward-looking. So it's very flexible. You can install it in almost every possible position. The only limitation is the depth of the sensor, which is 25 meters. But apart from this, you can orientate this quite freely.
Okay, so very flexible, fully flexible orientation, and then within the scanning swaths, it's possible to point those and point them in the direction you want to look. So here's one about depth rating. How deep can SeapiX be installed?
Yeah, so as I said, it's 25 meters depth rating. We don't have subsea version of SeapiX currently, and we are not working on this, to be completely honest. So we remain on a hull or quay or pier installation, but not deeper than 25 meters.
Okay, sure, that's clear. So looking at river installations, river applications, could SeapiX-C, would it be able to detect obstacles such as tree trunks?
We don't implement these features. We are working on object detection, which is more in the military market. So today what we could see, you can see the flow. So in the acoustic view, you could see this object. So visually, you will be able to see, oh, there is a flow of objects in my water column. You could maybe, we could also maybe use what we call the biomass assessment, because we can detect objects in the water, but it's not really like a tracking on an alarm at the moment.
Sure. Okay, so the answer is it doesn't do it today, but technically it's perhaps something that could be adapted if there was a strong interest in doing it. Here's one about someone thinks SeapiX looks a bit heavy. Is it suitable for pole mounting?
Yeah, it's not only looking, it's very heavy. It's like 68 kg for the stainless version. So it's why we also have a light version, which is 24 kg in air, and it is neutral buoyant in water. So depending on the application, sometimes like you saw for the Pentation, they don't care about 68 kg, which is permanently installed. But when you're in the Rhone River, you don't want to have this big baby to be transported and installed, so you can use a light version. So it's very dependent on the application and if it's permanent or just a few hours or days at a certain spot.
Sure. Yeah, so the standard model is heavy and it's ruggedized for a reason. It's to survive lengthy installations. We have a light model which is built from a composite material and takes a lot of the weight out of the system. It's 25 kilos or 24 kilos. Yeah. So pole mounting, no problem. Temporary mountings. So here's one about environmental performance. So how do you manage high levels of turbidity? And how can you track things, or can you operate in harsh environments?
Yeah, that's a very good point. Actually, the SeapiX, I didn't mention the frequency of the SeapiX is 150 kilohertz, so it's quite low compared with other multi-beam echo sounder. So we had a lot of experiments. I can tell about a river close to the sea, where you can have layers of mud which are going up or down depending on the swell here. And we can manage to go through this very thick material. So for rivers, sometimes it's hard to say what is the bottom. Is it this top layer, or is it just after the rocks, etc.? But we have a lot of experience about penetrating this thick mud, where other multi-beam we just detect the top of these layers.
Yeah. So the frequency being the key to the answer there, 150 kilohertz. And so people can hopefully imagine, based on some knowledge and experience, how it will deal with the turbidity. So what about bottom classification? You touched on it a little bit earlier. Maybe just a quick recap on how we can manage that.
Yeah, I think it's important to clarify what you call classification. When I hear classification, I think, okay, the instrument can say this is sand, rocks, mud, and also all this declination between all these main features. So today we don't have an automatic classification tool, but you have the methodology from the seafloor, or the bottom, actually. So because the calibrated instruments, you will get a very accurate value of what you call the backscatter, and that can be used to classify the bottom. Something important to know about is a backscatter depends on the incidence angle. So if you're in static position, you only get one angle at a certain location. So sometimes you have many or more than one possible sediment at that place because the curve of BS cross at that location.
Okay. So we backscatter information can be derived from the data, but we don't actually have an implementation of that in the standard product today.
Yeah. Well, what I can add maybe is we already have a map also of the backscatter. So you can have the map of the bathymetry, and we can have a map also on this bathymetry with the backscatter value. So if you have difference of sediment, you will see the pattern, the shape of it. So you can imagine, okay, I see the different pattern and have a real life assessment to have maybe divers or ROV to assess what is the features here. And when you are in a certain location, you know what are the possible sediments. So that's also a way to simplify the classification, but it's not automatic today.
Mm-hmm. Okay, good, that's clear. So we've got a question here now about, we touched a little bit on the frequency earlier, but there's a question about, what's the range, the number of beams, resolution. Give us a quick overview of that, if you could.
Okay, so for range, I can give you some ideas with sea fishery market. Sometimes we can hit the ground at more than 600 meters. So it's more than enough for the SeapiX application. So it's also based on the low frequency. There's less loss in the water due to the low frequency of the system. The resolution is very important. Each beams are 1.6 degree per 1.6 degree resolution. So it means you can't see two objectives are within this beam. And in terms of range resolution, we reach 7.5 centimeter resolution.
Okay, that's helpful. So 150 kilohertz, 7.5 centimeter range resolution, and 1.6 by 1.6. Yeah. We've got one here about cable laying. So do you consider that there could be some way of using this tool in touchdown monitoring of cables or cable laying operation?
It's one of the many ones we have in the basket. So we are still thinking about developing a SeapiX for more than the three applications we already state here. And cable laying is among them. Why is that? Is because the volumetric capability of the SeapiX. So you can imagine having a SeapiX installed at the back of the vessel, a little bit tilted, and having this 120 per 120 degree conic aperture. So we think we could detect the cable, and that we could detect the shape of the cable and maybe determine the bending radius, the incidence angle, and also build the bathymetry in front of this cable to see how it's happening. But to be clear, today it's not an existing solution. So we are more in the phase that we want to find a partner, maybe end user or operator that are in this field to deploy maybe a demo system and to test on the real life condition to see is it possible and what's the next move. It's physically possible. What's the next move to have a nice application, because you want something which is more or less also automatic and user friendly.
Sure. Okay. So the short answer is we think it's a very interesting application. There needs to be some software adaptation, and the idea would make a really efficient solution would be integrated in a customer's operation. So here's another one. What about long-term environmental monitoring applications? So somebody's thinking about biomass monitoring in wind farms, for example.
Yeah, I have a nice example. We got an order in Turkey for a European project, which is the monitoring of the transit of biomass from the Black Sea and the Mediterranean Sea. So it's around Istanbul area. So there's 6 independent autonomous buoy, so working with sun electricity, and that monitors the amount of fishes at a different time and period of the year. And actually, that's a good example of how SeapiX can be integrated in a different platform. Here we only have the SAU and an automatic BFU that runs script when it is started. So it's monitor, run a script, save the raw data that will be recovered later, and stream in real time pre-processed data to the shore. So in real time, they can see at this different spot what were the biomass located and shape and energy inside. Okay,
so the answer is yes, very well suited to that sort of application for permanent installation, and can be integrated with an operating system to define what it should do and manage data and data transmission and so on. Here's one. Somebody wants a demo. Can a demo be organized on a barge?
Yes, with pleasure. We already have some already planned. For example, in September, we'll have one with a customer, which is EDF, very important in France here. They are interested in the dam monitoring. We may have, depending on the lockdown period, one in July or August for a very nice one, which is for the nuclear plant. They want to prevent the biomass to entering the water intake. So they want to monitor around this water intake if there is biomass to avoid having them into the pipes. Mm-hmm. So yes, the answer is yes. We have one unit currently. And in a few weeks, we will get a second unit. Both of them, they are light version, so it's easy to deploy. You don't need to have big structure to hold the SeapiX.
Yeah, sure. Okay, so yeah, we're ready and willing to come and demonstrate the system at a customer site, or even we're doing demos frequently down at our facility in La Ciotat in the south of France. Yeah. So there's one about data formats. Can SeapiX operate with kind of open data formats?
Yeah, actually at XBlue, it's more or less the thinking we have. We like open formats. We like to be integrated to different software. It has already been done with OLEX software, EcoView for the biomass assessment, Caris when we do some hydrography, and all this stuff. So we have 2 ways to do so. We can record raw data and have converters, and we can have real-time stream from the BFU, which is let's say the black box of the system that can stream process data in a certain format. It can be open format, but also proprietary format. So that's all options are possible with the SeapiX, and that's quite easy to implement because the structure is already here with a certain number of existing format.
Okay, and that leads on to another question actually, which is how would SeapiX be interfaced with other software? You've touched on that a little bit there, but maybe you can just go through the components of the system just to...
Yeah, so it's to be very quick, we have the antenna, the first unit, which is more or less a power supply. Then what we call the BFU, which is the most important one, that does all the processing, all the stream in and out of the system, and the operating system of the customer that can be customized. On the BFU, we can integrate serial ports or Ethernet ports. It could be UDP, TCP, server or client, so we can define the different stream we want. And to interface and to have more control on the SeapiX, there is already an existing protocol. So somebody that can create a module that can directly ask to SeapiX, do this or do this scenario, and send me this data. So this is already implemented tools, so like a little bit like a SDK part of the SeapiX.
Okay, yeah. So it's adapted for integration with other systems and software. Here's one about another application. So can SeapiX detect gas bubbles coming from the seabed? Is it possible to determine the amount of gas?
Let's answer the first part. Yes, we did very interesting one in Garonne River, I think it was, where you have some gas leak from pipes. Mm-hmm. And actually, we could detect bubbles smaller than the optical detectable bubbles. Why is that? This bubble it's a high reflection with the acoustic. You see, it's it will transform your sound and reflect it very easily to you. So yes, we have a lot of experience with that. We followed a pipe, and you could see some plumes here, and it was very easy to detect it. To determine the size, I would say we could use the metrology about this, because each bubble acts like an object. So depending on the size, the acoustic answer will be different. So there's some rules, like physical rules. If it's a spherical bubble, you know that the diameter will give this TS value, for instance. So there is a certain way to come back to the size of the bubbles. Of course, if you have a mix of bubbles, you have like a spread histogram of this, and then you have to determine like more the statistics about the bubbles dispersion.
Okay, well that's really interesting. So the answer is yes, and yes, and yes. We can definitely detect bubbles, and we could certainly adapt a way to make some measurements, estimates of the amount of gas, or either with but that would need a bit of work to study the formula. I think that's it for questions. Oh no, we've got one more. Hang on, stand by, Maxence, stand by.
Yeah, I'm not leaving.
Yeah. Okay, it's about hydrography, and so can SeapiX be used in hydrographic operations? To deliver data for charting, IHO charting.
Yeah, it can be used. As I said, there is an integrated IMU. But so if you use integrated IMU, you will be like order 1A with AHO. But you can integrate with a nice motion sensor like iDreams, for instance, and then you can reach the special order, IHO special order. So this is possible. I won't say it's a main application of SeapiX, because you can find multi-beam echo sounder on this market, but it's possible to operate the SeapiX and get IHO results.
Okay, yeah. So it's feasible. It's not let's say the main goal of the tool, but it can reach a certain level of performance with the built-in motion sensor. But if you integrate it with a higher spec sensor, then you can get a special order IHO bathymetry output. There's another one. Does the built-in motion sensor include heading?
No, it doesn't. So you need to have or you don't need it. For instance, if I take the river example, actually the heading is quite easy to understand. So you don't really need to have the value, and you can enter an absolute value to get the right location of your spot. But if you want to be on board a vessel or motion platform, you will need the heading as an input to the system. So you only get with AMI the role, pitch, and also assessment of the HIV value.
Okay, yeah. So in the static operation, it's obviously a kind of a relative bathymetry type observation. If you want to go to something more sophisticated and get you know, real world coordinates for your soundings, then you need to orient the array in the real world. So you'd need a heading input of some sort. Any more questions? Is that it? Any more questions? I think we're done. Yeah, Maxence, that is the end. Thank you very much for your help. Thanks for the answers to those questions.
Thank you, David. It was a pleasure. Just want to say a few words about everybody. Just stay safe. I hope the lockdown period will end soon, but we don't know. So we keep here available to all your questions. You can ask your commercial contact, or you can find my coordinates on the SeapiX website. You will find a link shortly after this webinar. And also a big thanks to IT people, to you, David, to organize this webinar, to transform this lockdown period, not very fun, to an opportunity to demonstrate our product and to give you some clue of what are the progress with the system. And a last word to all people keeping working at Exail and delivering system every day. So that's we managed to do it, and that's a big thanks to all these guys here at Exail.
Thanks, Maxence.
Thank you. Bye-bye.
Okay, well, that's it for us for today. We will be repeating this exercise later in the day, but hopefully you've got an idea of SeapiX 3D solid state bathymetry tool. Hopefully you've had your questions answered. If you've got any more questions, then don't hesitate to contact us. If you want to see or imagine an idea to have a demonstration of the system in real life, then please let us know, because we're ready to demonstrate it. And in the meantime, before we can start traveling again, maybe there's an opportunity to demonstrate remotely some of the software applications that we can show you. So as I said earlier, this recording of this will be available on our website later, and I think the FAQ, so all the questions and answers, should also be available there. So we, as I say, will be repeating this webinar later today, French time. Stay tuned for news of future Exail events. There will be some coming up in the not too distant future. In the meantime, stay safe, and goodbye from us here in Paris. Bye.